My dear students, it has been nearly 22 videos in which we have studied different concepts of electrostatics. We have studied what the charge means, types of charges, methods of charging a body, the minimum charge that a body can acquire, properties of electric charges, Coulomb's law, definition of electric intensity, expression for electric intensity due to an isolated charge. And then we studied dipole, we studied the different properties of dipole, we arrived at the expression for electric intensity on the axis of an electric dipole, on the equator of an electric dipole, and we discussed Gauss's theorem. We discussed the applications of Gauss's theorem that has been prescribed. And then we went on to study the meaning of electric potential. And we also gave you the expression for electric potential due to an isolated point charge. We also derived the expression for electric potential due to electric dipole. We studied the concept of equipotential surfaces. We derived the relation between electric potential and electric intensity. And many other concepts have been studied already in our previous videos. Now it is time for us to study about a concept called capacitors. So generally ನಿಮಗೆ capacity ಅಂದ್ರೆ ಏನು ಅಂತ ಗೊತ್ತಿದೆ. Capacity ಅಂತಂದ್ರೆ how much ಅಂತ ಅರ್ಥ or ability ಅನ್ನೋ ಅರ್ಥದಲ್ಲೂ ಉಪಯೋಗಿಸ್ತಾರೆ. In the same context we use capacitors. We naವೆಲ್ಲ properties of charges derive ಮಾಡಬೇಕಾದ್ರೆ we told you that charges will be more concentrated when you charge the body. The concentration of charges is more where the radius of curvature is more. Radius of curvature is less or the curvature is more. If we take a, say for example, if we take a cube, get it charged by some method, the charges will be more concentrated at the corners and also at the edges. And hence, ನೀವು ಇದನ್ನು ಚಾರ್ಜ್ ಮಾಡಿದಾಗ the charges will rush to the corners, and because the charges are more concentrated at the corners, they repel each other due to electrostatic force of repulsion. The charges get relieved. So it becomes difficult to store charges on a device, or I mean to say a body. It is very difficult to store charges because charges get leaked. ಈ ಕೋನ್ ತಗೊಂಡ್ರು ಅದೇ ಆಗುತ್ತೆ. If you take a cone and if you happen to charge a cone, so ಒಂದು ಕೋನ್ ತಗೊಂಡು ನೀವು ಕೋನ್ನ ಚಾರ್ಜ್ ಮಾಡಿದ್ರೆ the charges will be more concentrated at the vertex of the cone, as a result of which there is electrostatic force of repulsion between the charges and the charges get moved. So this is a common phenomenon. There should be only one body that can save charges for a longer time or that can store charges. Uniformly curved surface of a constant one sphere. If you happen to charge a sphere, the charges will be uniformly distributed because of uniformity in the curvature, and hence the resultant force acting on this charge due to the neighboring charges will be zero. The charges can be stored. ಒಂದೇ ಒಂದು ಪಾಸಿಬಿಲಿಟಿ ನಮಗೆ ಚಾರ್ಜ್ ಸ್ಟೋರ್ ಮಾಡೋಕ್ಕೆ ಇರೋದು ಸ್ಪಿಯರ್ ಬಿಟ್ಟು ಬೇರೆಯವ್ರ ಮೇಲೆ ಚಾರ್ಜ್ ಸ್ಟೋರ್ ಮಾಡೋದು ಕಷ್ಟ ಆಗುತ್ತೆ. Means their capacity to store charge is very less. ಸ್ಪಿಯರ್ನ ನಾವು ಚಾರ್ಜ್ ಸ್ಟೋರ್ ಮಾಡೋಕ್ಕೆ ಉಪಯೋಗಿಸಬಹುದು, ಮಾಡಬಹುದಾಗಿತ್ತು. ಬಟ್ ನಾವು ಕೆಪಾಸಿಟರ್ಸ್ ಅಂತ ಒಂದು ಚಾಪ್ಟರ್ನ ಕಲಿತಾ ಇದ್ದೀವಿ ಅಂತಂದ್ರೆ ದೇರ್ ಶುಡ್ ಬಿ ಸಮ್ ಡಿಫೆಕ್ಟ್ ಈವನ್ ಇನ್ ದ ಸ್ಪಿಯರ್ನಲ್ಲೂ ಏನೋ ಡಿಫೆಕ್ಟ್ ಇರಬೇಕು. ಅದಕ್ಕೆ ನಾವು ಸ್ಪಿಯರ್ ಉಪಯೋಗಿಸೋದನ್ನು ಬಿಟ್ಟು ಕೆಪಾಸಿಟರ್ ಅನ್ನುವ ಒಂದು ಡಿವೈಸ್ ಅನ್ನು ನಾವು ಚಾರ್ಜ್ ಸ್ಟೋರ್ ಮಾಡೋಕ್ಕೆ ಉಪಯೋಗಿಸ್ತೇವೆ. Now capacitor will also be called by the name condenser. ನಿಮಗೆಲ್ಲ ಕಂಡೆನ್ಸ್ ಅಂದ್ರೆ ಏನು ಅಂತ ಗೊತ್ತು. ಕಂಡೆನ್ಸ್ ಅಂದ್ರೆ ಚಿಕ್ಕದು ಮಾಡೋದು. ನೀವು 2 ಪೇಜ್ ಲಾಂಗ್ ಆನ್ಸರ್ ಬರೆದ್ರೆ ನೀವು ಟೀಚರಿಗೆ ತೋರಿಸಿದ್ರೆ ಟೀಚರ್ ಮೇ ಗೈಡ್ ಯು. ಏನಪ್ಪಾ ಎಷ್ಟೊತ್ತ ಬರ್ತಿದ್ಯಾ, ಕಂಡೆನ್ಸ್ ಮಾಡಿ ಬರ್ಕೊಂಡ್ ಬಾ, ಚಿಕ್ಕದು ಮಾಡಿ ಬರ್ಕೊಂಡ್ ಬಾ. ಕಂಡೆನ್ಸ್ಡ್ ಮಿಲ್ಕ್, ಹಾಲನ್ನು ಕುದಿಸಿ ಅದರೊಳಗಿರೋ ನೀರಿನ ಅಂಶ ಎಲ್ಲ ತೆಗೆದು ಅದನ್ನು ಗಟ್ಟಿ ಮಾಡಿ ಕ್ವಾಂಟಿಟಿಯಲ್ಲಿ ಕಡಿಮೆ ಮಾಡಿ, ಕಂಡೆನ್ಸ್ಡ್ ಮಿಲ್ಕ್. ಸೊ ಕಂಡೆನ್ಸರ್ ಅಂದರೆ ಚಿಕ್ಕದು ಅಂತ. ಸೊ ಕಂಡೆನ್ಸರ್ ಅಂತ ಯಾಕೆ ಹೆಸರು ಬಂತು? ಡಿವೈಸ್ ಚಿಕ್ಕದು, ಆದರೆ ಇದರ ಎಬಿಲಿಟಿ ಟು ಸ್ಟೋರ್ ಚಾರ್ಜಸ್ ಜಾಸ್ತಿ, ಅದಕ್ಕೆ ಕಂಡೆನ್ಸರ್ ಅಂತ ಕರೀತೀವಿ. ಸೊ ಸಾಮಾನ್ಯವಾಗಿ ಕಮರ್ಷಿಯಲ್ ನೇಮ್ ಅಂಗಡಿಗಳಲ್ಲಿ ಕೆಪಾಸಿಟರ್ಸ್ ಅನ್ನೋದಕ್ಕಿಂತ ಕಂಡೆನ್ಸರ್ ಅನ್ನುವ ಪದವನ್ನು ಜಾಸ್ತಿ ಉಪಯೋಗಿಸ್ತಾರೆ ಮಾರಾಟಗಾರರು. ಸೊ ಬಿಫೋರ್ ಯು ಕ್ಯಾನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ವೈ ಯು ಆರ್ ನಾಟ್ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್ ಎ ಕೆಪಾಸಿಟರ್ ಆರ್ ಐ ಮೀನ್ ಟು ಸೇ ಎ ಸ್ಪಿಯರ್ ಫಾರ್ ಸ್ಟೋರಿಂಗ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜಸ್, you need to understand the definition of capacitance, or what does capacitance of a conductor mean, like that. So ಈಗ ನಮಗೆಲ್ಲ ಗೊತ್ತಿದೆ, we all know, if you keep increasing the charge on a conductor, the electric potential due to the conductor over its surface also increases. ಅಂದರೆ ನೀವು ಒಂದು ಕಂಡಕ್ಟರ್ನ ಚಾರ್ಜ್ ಮಾಡ್ತಾ 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 ಅದರ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ಗೆ ಕಾರಣನೇ ಚಾರ್ಜ್. ಸೊ ಕಾರಣ ಜಾಸ್ತಿ ಮಾಡ್ತಾ ಹೋದರೆ ಪರಿಣಾಮನೂ ಜಾಸ್ತಿ ಆಗ್ತದೆ. ಸೊ ದ ಇಫೆಕ್ಟ್ ಈಸ್ ಆಲ್ವೇಸ್ ಡಿಪೆಂಡೆಂಟ್ ಆನ್ ದ ಕಾಸ್. ಸೊ ಕಾಸು ಮತ್ತು ಇಫೆಕ್ಟು ಯಾವಾಗಲೂ ರಿಲೇಟ್ ಆಗಿರುತ್ತೆ. ಸೊ ಪೊಟೆನ್ಷಿಯಲ್ಗೆ ಕಾರಣ ಏನು? ಪೊಟೆನ್ಷಿಯಲ್ಗೆ ಕಾರಣ ಚಾರ್ಜ್. ಹಾಗಾದರೆ ನ್ಯಾಚುರಲಿ ಚಾರ್ಜ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋದರೆ electric potential ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Therefore, I can make a statement: increasing the charge on a conductor increases its electric potential. So you can make a statement. That means increase in the charge on a conductor. Charge ನಾನು Q ಅಂತ represent ಮಾಡ್ತೀನಿ, potential ನ V ಅಂತ represent ಮಾಡ್ತೀನಿ. So V is dependent on Q. Therefore, I can write Q increase in Q will increase V. So ಅದನ್ನೇ ನಾನು mathematical form ಬರೆದೆ. So after I write this, I replace proportionality by equal to, and I will include a constant. C is the constant that I have included. Is C idella? C another, C is the proportionality constant. And it is called the capacitance of the conductor. So conductor na capacitance anta karitare, proportionality constant. So Q is equal to C by P. C equal to Q by E. So capacitance of the conductor is the ratio of charge on the conductor to its potential. Simple. ಈಗ ಇದನ್ನೇ ಬೇಸಿಸ್ ಆಗಿ ಇಟ್ಕೊಂಡು we are going to define capacitance of the conductor. Capacitance of the conductor ನಾನು ಡಿಫೈನ್ ಮಾಡ್ತೀನಿ. How to define? ನೋಡಿ. So ಈಗ ನಾನು definition of capacitance ಅಂತ ಬರೆದು I will take this expression C equal to Q by E. ಈ expression ತಗೊಳ್ಳಿ. In this expression, if you take V as 1 volt, V 1 volt ತಗೊಂಡ್ರೆ then Q is equal to C. V 1 volt ಅಂದ್ರೆ Q becomes C. Now based on this I will define capacitance of a conductor. Now capacitance of a conductor is numerically equal to the charge required to raise the potential of a conductor by 1 volt. I repeat, capacitance of a conductor is equal to the charge required to raise the potential of the conductor by 1 volt. Meaning, ಯಾವುದೋ conductor ಇದೆ, say a spherical conductor. This has been already charged. Charge ಆಗ್ಬಿಟ್ಟಿದೆ ಇದು. Due to which, let us say, the electric potential on the surface of this spherical conductor is 50 volt. Charge ಆದ್ಮೇಲೆ naturally electric potential ಇರಲೇಬೇಕು, ಅದಕ್ಕೆ 50 volt potential. Now what I want to do is I want to increase the electric potential from 50 volt to 51 volt. 50 ಇರುವಂತದನ್ನು 51 volt ಮಾಡಬೇಕು ನಾನು. I need to raise the potential of the conductor from 50 volt to 51 volt. Then what I do? I add charges. I further charge the volt. So ನಾನು charge add ಮಾಡ್ತಾ there will be a rise in the potential. 50 becomes 50.1, 50.2, 50.3 and 50.4, so on. and reaches 51 if I go on adding the charges. So 50 in the 51 ಆಗೋವರೆಗೂ ಚಾರ್ಜ್ ಆಡ್ ಮಾಡ್ತೀನಿ. ಎಷ್ಟು ಚಾರ್ಜ್ ಆಡ್ ಮಾಡಿದ್ರೆ 50 ಇಂದ 51 ಆಗುತ್ತೋ ಅದನ್ನ ನಾನು electric potential of this conductor ಅಂತ ಕರೀತೀನಿ. Or taking another example, ಇನ್ಯಾವುದೋ ಬೇರೆ ಕಂಡಕ್ಟರ್ ಇದೆ, ಇದಕ್ಕೆ 99 ವೋಲ್ಟ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇದೆ ಬಿಕಾಸ್ ಇಟ್ ಹ್ಯಾಸ್ ಬೀನ್ ಆಲ್ರೆಡಿ ಚಾರ್ಜ್ಡ್. ಚಾರ್ಜ್ ಕ್ಯಾರಿ ಮಾಡ್ತಾ ಇದೆ. Now I am asked to raise its potential to 100 volt by 1 volt. So 99 ನಾನು 100 ಮಾಡಬೇಕಂದ್ರೆ I need to add the charge. So ನಾನು charges add ಮಾಡ್ತಾ ಹೋಗಬೇಕು. So if I go on adding the charges, 99 becomes 99.01, 99.02, 99.03, so on, and it keeps increasing and reaches 100. By the time it reaches 100, I have already added some charge. So that charge that I have added is its capacitance. So simple. So other than now, I will write it as a definition. So other than a definition, therefore, I am going to inverted commas. The capacitance of a conductor is numerically equal to the charge required can even write charge needed to rise the potential of the conductor by 1 volt. So this is the definition of electric potential. Sorry, capacitance, not electric potential, the capacitance. Now, what should be the unit of electric capacitance or capacitance? What is it? Q by V is the expression for capacitance. You know charge unit to coulomb, potential unit to volt. Unit na you can give of a conductor. Electric capacitance ke unit to coulomb per volt. Q by V, coulomb per volt. Or 1 coulomb per volt is also called 1 farad. Or you can also call it as farad, not Faraday. It's not Faraday. It is farad. Faraday no unit hai, but not for capacitance. It is for electric current or electrolyte. So I will define my 1 Faraday current. So chemists will define what is 1 Faraday current. Faraday is also a unit, but it's not for electric capacitance. It's for some other unit that will be taught to you in chemistry. So make sure that it is not Faraday, it is Farad. ಆದರೆ ಫ್ಯಾರಡ್ ತುಂಬ ಲಾರ್ಜ್ ಯೂನಿಟ್, ಅದಕ್ಕೋಸ್ಕರ they will use milli farad, micro farad, nano farad as the unit. But the SI unit is farad or coulomb per volt. So now, how to define 1 farad? 1 farad is the definition. So, you know, 1 farad should be equal to 1 coulomb by 1 volt. So unity by unity will be unit. So 1 by 1 is 1. So in the basis I will define 1 farad. So capacitance of a conductor is 1 farad if 1 coulomb of charge given to the conductor increases its potential by 1 volt. 1 coulomb charge ಕೊಟ್ರೆ ಅದರ ಕೆಪಾಸಿಟನ್ಸ್ 1 ವೋಲ್ಟಸ್ ಜಾಸ್ತಿ ಆದರೆ ಅವಾಗ ಅದರ ಕೆಪಾಸಿಟನ್ಸ್ 1 farad. Athwa you can also say capacitance of a conductor is 1 farad if 1 coulomb of charge removed from the conductor decreases its potential by 1 volt. Simple. 1 coulomb charge given value removed by the conductor or from the conductor decreases its potential by 1. So, ನಿಮಗೆ confusion ಬೇಡ, ಈ definition ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ. And finally, capacitance ಏನದು? Scalar quantity na vector quantity na? ನೋಡಿ, C is the ratio of charge to the potential on the surface of the conductor. Charge is a scalar quantity. Electric potential is also a scalar quantity. Previous videos are discussed ಮಾಡಿದೀವಿ ನಾವು. So, a scalar divided by a scalar, another scalar quantity will result in a scalar. So, hence, capacitance is a scalar physical quantity. So, dimensions variable. So, you get physical role in a part when very new physical quantity is introduced. You have to understand what that physical quantity is, and thereby you have to define it properly with a definition. You have to understand its unit. You have to define the unit. Okay, you have to define the unit. And finally, you have to give the dimensional formula. Dimensional formula correct. So, the homework for you in this video is you have to give the dimensional formula for this capacitance of a conductor. So, this is the video about capacitance. In the next video, we shall discuss about the dimensions for the capacitance, and also we will understand why SPR is not used to store electric charges.